Right. Good morning, good people. Once again, thank you very much indeed for taking the time and the trouble to be part of this lesson. My name is Hendrik Makaneta, and I'm going to teach you mathematics, grade 12, today being the 17th of October, 2020, as we continue to revise for the exams that are coming. And of course, this lesson is brought to you by the Africa Teen Geeks STEM Digital School. Now, without any waste of time, I'm just going to zoom directly into the outcomes of the lesson, or the contents rather. By the end of this lesson, we should be able to find different forms of unknowns ranging from the value of n, where n represents the number of years, where P represents the principal amount. So basically, you will be given some of the formulae to work with. And of course, you should be able to use them to find the accrued amount together with the percentage, as well as the number of years and the principal amount in this case. And today we are wrapping up that lesson on finance. And of course, just to bear in mind, just always keep the rate of interest per time unit as well as the time period in the same units. It's very important to also note that there will always be a distinction between the different interests. We have already spoken about the simple interest, which can be found using the proper formula. Like in this case, for simple interest, A will always be equal to P into 1 plus IN. And of course, the same goes for the compound interest, which will be different in a sense that now your N, which used to be the coefficient of I, is now the exponent. So the compound interest formula quite different there. And the simple depreciation, we also call this the straight line depreciation. I'm sure that in the previous lessons you might have been taught about the straight line depreciation. This is the value of any good that is now reduced or depreciated in its value. Now, we also have the compound depreciation, which we have also looked at. Remember, we spoke about the straight line depreciation as well as the reducing balance depreciation. So another word for a simple depreciation is called straight line depreciation. And whereas compound depreciation, we also call it the reducing balance depreciation. So at times you can be asked to calculate the compound depreciation for a vehicle. You must know that the formula that we use is that of the reducing balance depreciation. So both of them talk about the reduction of value. That is why we see the negative sign. So if you can check the difference really between the four formulae there, the first one and the second consist of a plus sign. As you can see, A is equal to P into 1 plus IN. That is the simple interest, and the compound interest, A is equal to P into 1 plus I to the power of N. And of course, the difference here will be the negative sign when you look at the straight line depreciation as well as the reducing balance depreciation. The formula for the simple depreciation is the same as the one of the simple interest, except for the negative sign. So the negative sign simply means that you are now going to reduce the value. The original value of the car will be reduced. That is why we call it the simple depreciation. So, or the straight line depreciation. And of course, we have spoken at length by now about the effective and as well as the annual interest rate. But I also want to talk about the future value of payments. In this case, when you look at the value of payments which can be made in the future, there's a formula that we have which can be utilized as well when you want to calculate the payment amount which will be made in the near future. Right. I will not waste time. The new example now for today here, Sipho invests 500 rands, which earns interest at 6.81% per annum, and realize that this will be compounded quarterly. So the key question that arises out of this investment is how long will it take for the investment to have a balance of 749 rands and 77 cents? So as I always say, it's very important to analyze your question. And how do you analyze your question? By looking at the given information. So what is very important, or what is key, is to take your pen and paper and write down all the given information which is there in the example. So you can tell without any doubt that you are given 500 rands. But what does 500 represent in this case? That is the key question that must also be answered. And of course, you also have 749 rands and 77. So you are given two different amounts, and you need to be able to classify this amount accordingly. So Sipho invests 500, which earns interest at 6.81% per annum, which is compounded quarterly. Remember the key word there, quarterly. What does that mean? It means it is compounded at least 4 times in a year. Remember that a year consists of 4 quarters. So there are 4 quarters in a year. So now, and a quarter of a year, obviously that will be 3 months out of 12 months. That is why it gives you a quarter there. Right. Let's start with identifying the different given information here. The first one, of course, is 500 rands. And what does this mean? This means that when Sipho went into the bank to make an investment, the principal amount, something which is known as the principal amount, this is the value of P. This is also known as the original amount, which is made into, or which is invested rather. So P in this case will be 500 rands. So Sipho invests 500 rands in the beginning. And of course, we know that this 500 rands will also get some interest. But before we get to the interest, we also look at the amount which is known as A. We also call it the accrued amount. So we are given the accrued amount, and we are told that after a certain number of years, the accrued amount will be 749 rands and 77 cents. So basically, this is what we know. And of course, the interest is at 6.810. So 6.81% per annum. Now, the other thing that we need to remember is that always when you are given interest, you need to divide by 100. So you are going to take your calculator now and divide 6.81 by 100 in order to get the proper figure that we're going to use in our formula, which we will also talk about shortly. So if you divide 6.81 by 100, you will get 0.0681. So basically, this is what you have. So to recap what you have there, you can tell that we have the A there, which is 749 Rand and 77 cents. We also have the P, which is 500. And we also have the I, which is 0.0681. And we've just calculated it now by dividing 6.81 by 100. So if you divide 6.81 by 100, you get 0.0681. Now, in order to choose the formula, whether the correct formula there, you need to realize that our value, our investment, is invested at this interest, which is compounded quarterly. So now when we talk about compounded, the word compounded is the past tense of compound. So it means we are compounding our interest. Therefore, we need to use the correct formula for compound interest. And that formula is given at the top there. A is equal to P open bracket 1 plus I close bracket to the power of N. So basically, this is the information that we have. And once you write it down as follows, then you should not have, or you should not experience rather any problem, because you can see that out of in that formula, there's only one a variable which is not given, and that variable is N. So you can see that we do not have N, and N stands for rather the number of years or the number of times that it will take for the investment to grow from 500 to 749 rands and 77 cents. So now we are going to zoom directly into our calculation. And basically in this question, the interest which is payable, as I've already said, is 0.0681. And you can tell even without any doubt that you need to divide that interest by 4 quarters there. Remember that a year consists of 4 quarters. So you are going to divide your interest by 4, right? And thereafter, you do realize that we are going to multiply N by 4. The reason why we are doing this is because our interest is compounded 4 times in a year. So whatever number of years there, you multiply that by 4. That is why we have used the formula as it is. A is equal to P open bracket 1 plus I close bracket to the power of N. So you multiply your number of years by 4 there, because in a year there are 4 quarters. So you can tell that once you have inserted once you divide 0.0681 by 4, and then you add 1 there, you will get 1.01702. So it's a recurring a decimal, and the exponent there will be 4n now that we have multiplied n by 4. And this type of problem, you are undoubtedly going to need the knowledge of the logs, because you cannot easily solve the exponential variable without using the logs. Otherwise, you can use the trial and error method, which may take you some time, and it may not always be accurate, given that we also have the decimal numbers there. So basically, you use the logs, and of course, the log of 1,499, if you divide that by the log of 1,01, you get 24. So at the end of the day, 4n will be equal to 24. So in order to find the number of years before we solve for n, we know that we have to now make n the subject of the formula. It means you must divide the left-hand side by 4. Remember that whatever you do in the left-hand side should also be done in the right-hand side. So we divide both sides by n, and therefore 24 divided by 4 there, you get 6. So n, or the value of n, is going to be 6. And this simply means that it will take you 6 years. It will take SIPO 6 years to invest 500 rand, which will grow to 749 rands and 77 cents, which is compounded quarterly at an interest rate of 6.81%. So basically, this is what we know, and of course, that is that. And this explains how we have been able to calculate the number of years. So the correct formula in this case is very important. You need to use the right formula to find your value there. So once you identify the right formula, and in this case, the keyword is compound. So we know that our interest is compounded quarterly, and that is why we have used it to find the number of years. So it will definitely take you, or it will take SIPO 6 years, which is the number of years there, to calculate or to grow his investment from 500 rands to 749 rands and 77 cents. Right. And of course, we have done this. I've just been demonstrating here that the end result will lead to 4n, which is 24. And you know that if you multiply 4 by 6, you get 24. Therefore, it means that the value of n will be 6. So it will take you 6 years. Now, we also want to look at an investment here which was made into a savings account. And this investment was made at an interest rate that pays 7.5% per annum. Once again, this is compounded, but this time we do not compound it quarterly, but we compound it yearly. So the word yearly, and you know, it means every year. It simply means once a year. So if you hear the word yearly, that is once a year. So we are also told in this case that after an unknown period of time, this account will generate an amount of 4,044 rands and 69 cents. Once again, we need to know for how long was this investment made in order to receive this, or in order to yield this amount of 4,044 rands and 69 cents. So once again, just as we did with the previous example, you will recall that in this previous example, we looked at the given information there. We also looked at the formula that we are going to use. So basically, what you have done in this example, the previous one, you use the same method. So in other words, your formula to calculate the number of years there, you'll have to use the compound interest formula. A is equal to P into I plus 1, close bracket, to the power of n. So the difference here is that the principal amount that is given is no longer 500 rands, but it has now increased. It is now 3,500. So you write it down. Very important, write down the given information. So you write down 3,500 rands. This is the principal amount, also known as P. So P here is 3,500 rands. Now you also identify A, which is now the accumulated amount or the accrued amount. So the accrued amount in this case will be 4,044 rands and 69 cents. So you need to be able to write it down. So it's 4,044 rands and 69 cents. So you must write it in full. So the accrued amount will be 4,044 rands and 69 cents. But what else do we have? We also have the interest. Remember that I said always, you need to remember that when you are given interest, you must divide by 100. So 7,5. I'm emphasizing this because there are learners who will just substitute the percentage as it is. You know, some of the learners may come to a misconception of just putting 7,5 as it is in the equation. Once you do that, you render yourself to a wide range of problems in a sense that you will not be able to get the correct answer. And the sad part about this is that if there's a recurring question, it will probably affect the marks of the next question as well. So it's very important to do the right thing first and foremost before you can even think of calculating or using the equation rather. So you are going to divide 7,5 by 100. And once you divide 7,5 by 100, you will see that the answer will be 0,075. So basically, that is your interest, which is compounded annually. So yearly and annually, they mean the same thing. Now that you have all the information except for one, where you don't have n, so you can see that in that equation there, we had A is equal to P, open bracket, 1 plus I, close bracket, to the power of n. So now is the time to find the missing value there, and the missing value is n. So in other words, we need to know, as we did with the first example, how long will it take for this investment to grow from 3,500 rands to 4,044 rands and 69 cents. So basically, this is what we need to do. Now, you will see that, as I've indicated, you once again use the same formula for compound interest. And then where there is A, you put 4,044 rands and 69 cents. And where there is P, you put 3,500 rands. And of course, I've already divided 7,5 by 100 to get 0,075 for the interest. And then if you add that to 1, it gives you 1,075. And then, of course, the exponent is n. Once again, I'm not saying that the logs are the only things that you should use in this case. You are welcome to try the trial and error method. It may lead you to a good answer, in a sense that usually when we use a trial and error, you can start by substituting n there. In other words, you can divide 4,044 rands and 69 cents. You can divide that by 3,500. Once you do so, you will see that the answer that you'll get will be a decimal fraction, which will be 1,155,625, which is a recurring decimal. And of course, you can use trial and error now to put in the value of n. For instance, you can, if you put 1, if the value of n is 1, you can see that the left-hand side will not be equal to the right-hand side. But if you put 1,075 0.075, if you put this to, to the power of 2, in other words, if you just multiply 1,075 by itself, the answer that you get there will be 1,155,625. So you'll see that without waste of time, it will definitely, this trial and error will work. You'll see that it works for the value of n, which is 2. So if n is 2, then the left-hand side will be equal to the right-hand side. But the quickest way to resolve this type of problems is to use the logs, in my view. If you have the basic understanding of the logs, then you can quickly put in the logs. And of course, with the use of your calculator, of course, you can just see that the log of the decimal number there, when you divide the accrued amount by the principal amount, if you divide everything by the log of 1,075, you'll definitely get 2 if you use your calculator. So this means that it will take 2 years for an investment of 3,500 rands to grow to 4,044 rands and 69 cents. So it will definitely take 2 years there. So that will be the number of years. And basically, this is what I've been trying to show you, just as we did the first example, to say you are likely to get such kind of problems in the exam where you need to calculate the number of years in a particular investment. And of course, the two examples are the same. The first one that I did is the same as this second one. They are basically the same. And I hope that it helps you to resolve quite a number of problems. We want to emphasize the whole point of the simple depreciation as well as the compound depreciation. I said to you, there's a simple depreciation is another word for straight line depreciation. So this is what I want to emphasize today. And again, the compound depreciation is another word for the reducing balance depreciation. So wherever you are now, please note that you can always get different terminology just to understand both. The simple depreciation stands for the straight line depreciation, and whereas the compound depreciation stands for the reducing balance depreciation. And I spoke about this when we started our lesson. I'm sure you'll recall, and this is what I said. I said to you, when you look at I just want to go back to what I said in the beginning. Yes, this is the slide. I said to you that if you look at this for the first 4 formulae, the third one there is simple depreciation. And we said that A is equal to P open bracket 1 minus IN. And of course, this also stands for the simple depreciation. And of course, the compound depreciation there stands for the reducing balance depreciation, whereas the simple depreciation stands for the straight line depreciation. And that is the concept, or those are the two concepts that I wanted to really emphasize this morning to ensure that we are all on the same page with regards to terminology. So if the question is asked in a different format, then you should be able to answer without a problem. And of course, basically this applies a lot when it comes to the values of vehicles during which you buy a car and the car loses value after a number of years. And in this case, the value of the car, you can see there, it is bought at 385,000 rands. and of course, it will lose its value after a period of 6 years. So now you can use two types of depreciations. You can either use the straight line depreciation, which is also known as the simple depreciation, or you can use the reducing balance depreciation, which is also known as the compound depreciation. And I like the two words compound depreciation and simple depreciation because they automatically direct you to the correct formula. So once you know that the reducing balance depreciation is the compound depreciation, then you will not struggle with selecting the correct formula. Remember that you will be given these things, different types. You have to select a formula amongst many, but given a sheet alone is not enough. The formula for the sheet that you're going to use is not enough. So you need to remember this by heart, or you need to know it by heart, in fact, the formula for the different types of depreciations. So in this case, we should be able to calculate that once again, identify what is given, and so that you are able to calculate what is not given there. Now, we are going to continue now just to demonstrate that when you use any simple interest formula, the given information there will be your P, as well as the interest, which is at 6% per annum, and of course the number of years. You are also given the number of years there, which is 6 years. So meaning that the accrued amount is the one that you need to calculate. Others call it the accumulated or the accrued amount and so on. But you do realize that this value will definitely decrease, in a sense that we are now working with what is called depreciation. So if you multiply 385,000 rands by the contents of the bracket there, you can see we have 1 minus 0.06 times 6. We know that 0.06 times 6 will give us 0.36. And of course, if you subtract 0.36 from 1, you get 0.64. And this will mean that your accumulated amount, or your new value there, then that will be 246,400. So this shows that after a number of years, the value will decrease. After a number of years, this value will decrease, and it will come down to 246,400. So now that I've done this example, even before, I want us to look at the value of the car after a period of 10 years. What will be the value of the car after a period of 10 years? So basically, what you need to do, you know that the period of 10 years now, it means 6 will be your number of years there initially, but now that we're looking at 10 years, then it means n will be 10. So in the same note, you have to multiply 0.06, which is now the percentage. You need to multiply that by 10. And of course, you'll see something very interesting here. Once you multiply 0.06 by 10, you will get 0.6. So basically 0.6 will be your answer. And of course, you have to subtract this from 1. Now, if you subtract this from 1, you'll get 0.4. So 0.4 will be the answer. And now, if you multiply 0.4 by the amount that we had there, 385,000. So if you multiply this by 0.4, you will see that the amount will be 154,000. So you can see that after a period of 10 years, the value of the vehicle will be 154,000 rands. So it will reduce drastically. And suppose you have to look now at the value of the same car after a period of 20 years now. Now, if you are going to use 20 years, it means again you need to multiply 0.06 by 20. And you will see something very interesting here, that after, if you multiply 0.06 by 20, you get 1.2. Now here is something very important. 1.2 is bigger than 1. So now if you subtract 1.2 from 1, of course, you'll be left with 0.2, which is negative. So you'll have minus 0.2. Now, if you multiply negative 0.2 by the amount that we had, 385,000 rands, you will see that your amount will come to negative 77,000 rands. So it means, this simply means that the car shall have lost its value after a period of 20 years. So basically this is what it means, because you now have the negative number there. You'll have a minus 77,000 rand. So it means the value of the car will be depleted after 20 years. And that is why things such as service book and so on, they work for a particular period of time, right? If you compare this with a compound interest, you will see that the compound interest formula is different in this case when you look at the reducing balance depreciation, where you will also be able to calculate that after a period of 10 years, you can look at that. But for now, in this case, we have looked at the value after a period of 6 years. And we can see that after a period of 6 years, the amount will be 154. In fact, it will be 265,599. That is after a period of 6 years. And like I said, you can do the same with the period of 10 years, whereby your exponent now becomes 10. And you will see that there will definitely be a different amount as well, in a sense that 10 years, a 10-year period, the amount will be different as compared to, it will be further reduced, in fact, than the 6-year period. So in 6 years' time, it will be better, but after 10 years, this will be drastically reduced. And of course, this is what we have spoken about, that there's a huge difference between the depreciation, which is simple, as well as the compound depreciation. So we are going to now use this experience to look at the different rates of interest, which are compounded as well. So for instance, I've already spoken about the nominal interest rate as well as the effective annual interest rate. This I've done before, I believe, but I want to emphasize the need to demonstrate that when you look at the investment which is made for a period of 1.5 years, and that would be 18 months, you need to be able to calculate the value of the investment at the end of the period, which is 1.5 years or 18 months. You need to be able to calculate that investment, together with the effective annual interest rate, especially if the nominal interest rate is given. So in this case, if you are told that the nominal interest rate is 8%, for instance, which is compounded, again, you need to remember that compound interest works faster than a simple interest. So in this case, you can look at the different options that are there, whether you are calculating on a yearly basis or half yearly or even quarterly. And you can see that when you calculate your interest on a daily basis, it seems to generate a lot of money rather than the annual interest. And the same goes for the calculation of the effective annual interest rate. This effective annual interest rate will also increase as you probably move from annual calculations of interest as well as daily. So there's quite a huge difference between calculating the interest on a daily basis as well as quarterly and of course yearly as well. When you do it quarterly, it can be much better than when you do it annually, because at least you have to get interest 4 times in a year, whereas in annually means you'll just get interest once a year. And of course, this also goes on to say we really need to find a way to observe the trend in relation to the accumulated amount. And of course, we have to now proceed to the next example where we need to look at the money that will be generated when you sell your plot. So we have looked at this, we've seen the trend, we've seen the effective interest rate. It increases as and when the interest is calculated on a year, whether it's yearly or daily. So we've already said if you calculate it yearly or half yearly, for instance, it will not generate a much effective annual interest rate than when you do it daily. So if you calculate your interest on a daily basis, I'm talking about that nominal interest. If it is generated daily, then it will lead to an increase in your effective annual interest rate. So basically, this is what I'm saying. And I hope that it makes sense. Now, I'm just going to go to the example of this West Coast plot where we need to sell, the owner needs to sell the plot. And of course, this plot costs 300,000 rands. And of course, there's a money or percentage of commission which also needs to be charged on the selling price. And the buyer might look at paying more than what the seller needs. Remember that in every sale, there's a buyer and a seller, and in between them, there's a middleman, sometimes known as the agents or the estate agents, who also sell the property on behalf of the seller. And in this case, the estate agent requires 7% commission fee on the selling price. So in other words, the commission will be 7% of the entire amount which will be sold. So in other words, once the 7% has been subtracted from the selling price, then we will be left with 300,000 rands. That is basically what it means. And of course, you can use variables to find your unknowns there. If your selling price is X, for instance, you can use X or you can use any variable. Even K is fine. If your selling price is X, then you know that when you multiply the percentage by the selling price and you add the price that is needed by the owner, you will definitely get the selling price there. And of course, if you have to now make K the subject of the formula or X the subject of the formula, you'll realize that the coefficient of K is 1. So if you take 1 and subtract 0.07, you will be left with 0.93. So 0.93K, this will be what is left. And if you divide now remember that I always say whatever you do in the left-hand side should also be done in the right-hand side of the equation in order to keep your equation balanced. So the coefficient of K there is 0.93, and we need to get rid of the coefficient by dividing by 0.93. So you divide it by itself, but like I said, whatever you do in the left-hand side should also be done in the right-hand side. And in the same note, what you do in the right-hand side should be done also in the left-hand side. So we also divide by 0.93 to get a value now of 322,580 rands and 65 cents. So basically, that is what it means. And then if you take that same amount and divide and subtract, in fact, if you take 322,000 rands and divide by and subtract 300,000 rands, you will get your commission there. So that amount that remains, which means 22,508 rands and 65 cents, that is the commission for the estate agent, and the commission will be taken there by the estate agent. And we have basically covered a lot of ground in relation to these future values. We have looked at the selling price, but equally we have looked at the number of years that will take for an investment to grow from one amount to the next. And we have also looked at the value of the car, which will depreciate after a particular number of years. So you have to remember now that when you buy a car, the value will decrease. We will also look at the value of the house at some point when we look at how usually it will be a different formula as compared to the one that we have for the car, in a sense that the value of the house will not depreciate. There is no depreciation when it comes to the value of the house, but there's a formula that we use to calculate how much value your house will be after a number of years. Right. I want to look at the difference between the simple interest as well as the compound interest, but I think at this point we have done a lot of justice to that. And the example that comes to mind is the one that we had on Cindy, who invests 500 rands. I've already dealt with that, so I will not repeat it. Right, and of course, what I want to emphasize once more is the difference between the two formulae, the simple growth as well as the compound growth, but the same things or the same concepts exist in both instances. For instance, you have A, you have P, you have I, you also have N in both instances. So the terminology is very important, where A stands for the accrued amount and P stands for the principal amount, whereas I stands for the interest rate. And N can stand for the number of times interest is calculated. So remember that, not necessarily the number of years. Yes, if it is per annum, in most cases it can be the number of years, but sometimes the interest can be compounded quarterly, for instance. So you need to know how many quarters are there in a year. So that is what I'm trying to imply here, to say the number of times interest is calculated is known as N. And then we should also remember that the accrued amount will be the amount that will be received at the end of the investment. So that is the accrued amount at the end of the investment. And this is not the same as the interest end. This is the total amount. It means this is the original amount that you invested plus the interest, and that gives you the accrued amount. Once more, I want you to remember the importance of the interest rate, that you must always divide the interest rate by 100. In all calculations, you must divide by 100 to avoid the mistakes. I gave you the example of the 7.5%, and I said there are learners who sometimes come to a misconception of just installing 7.5 as it is. So once you do that, you run the risk of losing your correct values, especially the accrued amount. You may not get the correct accrued amount. And if there's a follow-up question on the question that you have done where the misconception took place, you are likely to lose marks also in the next follow-up question. So it's very important to do the right thing the first time so that you don't lose the marks along the way. And then again, there is this element of the type of options which one can make, especially if you are faced with two different scenarios. Scenario one there, we know that Thabo wanted to borrow 5,000 rands, and the options that are there, we have option 1 and 2. In option 1, there's a simple interest rate of 15% per annum. And of course, this will be calculated for 2 years. That is the number of years. But then the other option, there's an option of 5% compound interest per month, also for 2 years. Now, what would be the best option now? Is 15% per annum too much to pay? When you look at the number of years, it's 2 years here. Remember, this is simple interest. So if you pay, is it cheaper or is it, yes, the question is it cheaper to pay 15% simple interest, or is it cheaper to pay 5% compound interest? Now, in order to know this, you need to always remember the correct formula that you need to use at all times. Remember that for the simple interest, A is equal to P open bracket I plus 1 plus IN rather. And the compound interest, A will be equal to P open bracket 1 plus I close bracket to the power of N. Now, 15% sounds too big. It's bigger than 5%. There's no doubt about that. Now, a lay person who may not have studied mathematics at this level of grade 12 will automatically go for the 5% interest because 5% is less. Remember, the period of borrowing such money is the same. Both of them is 2 years. So the one person who does not know mathematics may opt for 5%. So, for instance, we are told that Thabo decided to go with option 2 as the interest rate was lower than what his friend offered. So the question that must be answered now is whether Thabo made the right decision or not. If not, support your answer with calculations. So it should be very clear for us, mathematicians at the go. It should be clear at this point that Thabo made a wrong decision, or he made a wrong selection there. Option 2 is not the right selection, in spite of the lower interest, which is now 5%, because there's a huge difference between compound interest and simple interest. Now let's look at option 1 now. If Thabo had gone with option 1, he would have to now follow the simple interest rate formula. A is equal to P into 1 plus IN. The reason why I've decided to divide this particular I by 100 is because every time or each time when you work with interest, you need to divide by 100. So your interest has to be divided by 100 in order to become an interest rate that you can use. So you must always divide. Whenever you have 7%, this means it's 7 out of 100, right? Now we know that in option 1, the interest rate there is 15%. And it is for this reason that we divide 15 by 100, as you can see in the screen. And of course, we multiply it by the number of years. In this case, the number of years is 2. It's just 2 years. And thereafter, you should be able to see that when you divide 15 by 100, you get 0.15. And if you multiply 0.15 by 2, you get 0.3. And if you add 0.3 and 1, you get 1.3. And of course, if you multiply 1.3 by 5,000, you get 6,500. So this will be the accrued amount now on a loan that was taken under option 1. Remember that this loan has to be paid over a period of 2 years, as we know. And now we also know that 2 years consists of 24 months. So 2 years and 24 months means one and the same. Now, it is for this reason that we now divide 6,500 by 24. And if you divide 6,500 by 24, you'll get 270 rands and 83 cents. So this is basically the amount which SIPO can pay monthly for a period of 2 years. So every month, SIPO will be able to pay 270 rands and 83 cents. Remember, this is at an interest rate of 15%, which is a simple interest rate. So the simple interest there is 15%, which looks bigger than the 5% compound interest. So now we are going to demonstrate that option 2, which was selected by SIPO, was not the right option, in a sense that option 1, SIPO would have had to pay 270 rands and 83 cents. Now let's go and look at option 2. Now, if Thabo chose option 1, he would have paid 270 rands, as I said, and 83 cents per month for a period of 24 months. Now, in option 2, you can tell without doubt that 5%, although 5% looks smaller, but the fact that it is compound interest, it actually compounds the problem. Thabo's problem becomes worse. under option 2, because 5 divided by 100 will give you 0.05. And if you add 1 there, you get 1.05. And then to the power of 24. And when you multiply, it means you must multiply 1.05 by 1.05 by 23 times. All right? And of course, you multiply the answer with 5,000 to get a total amount of 16,125 rands and 50 cents. So you can see now that the value has now increased. 16,125 rands and 50 cents divided by 24 months. Now, if you divide this amount by 24 months, you will get 671 rands and 90 cents. And this is option 2. Now, Thabo will have to, now that Thabo chose option 2, it means he will have to pay 671 rands and 90 cents per month for a period of 24 months. Whereas in option 1, he would have paid 270 rands and 83 cents. Now, from the calculations that we have just done, it is very clear that Thabo made the wrong decision, because with option 2, he will pay a total of 9,625 rands and 90 cents more, and a monthly amount of 401 rand and 7 cents more than he had chosen option 1. I hope that you will not just answer this question like Thabo did. You will be able to work it out first in order to make an informed decision, because some things may look easier, at face value. But once you consider the calculations, then you will see that actually they are not as simple as they look or as they sound. So basically, Thabo made a wrong choice, and we know that he could have chosen option 1, despite the fact that 15% sounds like more than the 5% interest. Right, I'm just going to demonstrate now that if you make an investment and of course you compound your interest, for instance, quarterly, which means it is 4 times in a year, you must also divide the actual interest by the number of terms. For example, 4 quarters in a year, it simply means if the interest rate there is 12%, it means you will get 3% each time, because each quarter, because there are 4 quarters in a year. So if you divide 12 by 4, you have 3%. So remember, this is a compound interest again, so you need to be able to use the correct formula for the interest rate. Now, if 10,000 rand is invested at 12% per annum, compounded quarterly, you can be able to look at the table where the left-hand side or the first column there is the quarter that has passed, and the right-hand column there is the value of your investment. So you can put it in the value there. And basically, this is what investment companies do. They use a spreadsheet during which they enter the formula into the spreadsheet. And once they put in all the given values, then the spreadsheet will automatically calculate the value of the investment after a particular period of time. And this goes for even those investments that where interest is charged on an annual basis. There are some investments where interest is generated on a daily basis. There are those that where interest is generated annually, or those that are compounded quarterly, meaning that it will be 4 times in a year. Now let's look at this 1 year now. I said the quarter, as soon as you make your investment, we start at zero. We all start at zero. Everything actually starts at zero. Even the car, if you have to drive a car, you always start at zero before you can generate or get some speed. Now the same goes for the investment. In terms of the period of investment, you start at zero, and then you move to 1, 2, 3, and 4. So the value of your investment at zero, meaning at the beginning of your investment will be 10,000 rands. So basically this will be 10,000 rands. And you can see that after the first quarter, now we can see some movement. We can see some developments with regards to the value of your investment. Since 10,000 was invested in the beginning, then and coupled with the fact that we are using compound interest, you can use the correct formula there. The main thing is to always use the correct formula. And in this case, the correct formula will be A is equal to P open bracket 1 plus I all to the power of N. And the reason why we're dividing I there by 100 is because we want to always emphasize the point that percentage always must be divided by 100. That is a must. So now P, the value of P is 10,000 rands. And of course, the interest will be 3%. Remember, we have divided 12% into 4. In fact, we have divided 12% by 4 to get 3%. Every quarter, you get 3%. So now the number of years is just 1 year because there are 4 quarters in a year. So we put N there as 1. And we also divide 3 by 100 to get 0.03. And if you add 0.03 and 1 there, you get 1.03. So basically, that is what you have. And then if you multiply 1.03 by 10, then you get 10,300 rands. So this means that after the first quarter there, at the end of the first quarter, you get the value of 10,300 rands in your investment. So if this investment was made in the beginning of the year, on the 1st of January, or a particular year there, it means on the 31st of March, because 31st of March will be the end of your first quarter. It means that by the end of March, your value will be 10,300 rands. And then you do the same with the second quarter. You do the same with the second quarter. In the second quarter, once again, the most important thing that you need to realize in this case is that when you look at the second quarter, you are bound to change your principal amount. Now, at the end of the first quarter, your accumulated amount will be 10,300 rands. Now, at the beginning of the second quarter, when you start now on the 1st of April, and you want to reinvest that money, it means your accrued amount, which is 10,300 rands, now becomes your principal amount. It now becomes your principal amount. So therefore, you use the same formula. A is equal to P into 1 plus I to the power of N. So this means now P is 10,300. So you can see that at the end of the second quarter there, to calculate the investment, your P becomes 10,300 and your percentage is still the same. Remember, we have already divided 12 by 4 to get 3. So it means every quarter you get 3% in the same year, which is 1. So N there is 1. Interest is 3%, which becomes 3 over 100. And of course, if you divide 3 by 100, you get 0.03. And you add 1 there, you get 1.03. If you multiply it by 10,300, you will get 10,609. So the end of the second quarter, your accrued amount now becomes 10,609 rands. So this will be the value of your investment at the end of the second quarter. All right. And the second quarter will end on the 30th of June. That will be the second quarter there. And then on the 1st of July, that is the beginning of the third quarter now, which will end at 30 September, your value of the accrued amount, which was accrued in the second quarter, becomes now the principal amount. And then you put it in the same equation where A is equal to P, open bracket 1 plus I, all to the power N. We say interest there, we emphasize the point of dividing by 100 in order to avoid unnecessary mistakes. And of course, you follow the same procedure. The N value there is 1. You divide 3 by 100. Once again, you get 0.03. You add 1, and then you get 1.03. And if you multiply 1.03 with 10,609, you will be able to get the correct answer there, which is 10,927 rands and 27 cents. And as you move now from the beginning of October to the 31st of December, which is the last quarter now, your accrued amount in the third term becomes your principal amount in the fourth term now. So the last term there, or the last quarter rather, your accrued amount in the third quarter becomes your principal amount. And in the same way, you put it into the equation, and as always, you divide 3 by 100 to get 0.03, and you add 1 to get 1.03. And if you multiply 1.03 by 10,927 rands and 27 cents, you will definitely get the correct answer there, which will be 11,255 rands and 9 cents. Remember, the decimal there was 11,255 rands, 0.881. So you just round off there in order to have two figures. You round to 2 decimals, and of course, it will be 0.9 there. So 11,255 rands and 9 cents. So we call it 9 cents. 0.9 is just 9 cents. So basically, that is what you have. At this point, we look at the final amount now, which is 11,000 255 rands and 9 cents. And of course, we can tell without any doubt that our investment has grown by an amount of 1,255 rands and 9 cents. So in other words, your investment has grown from 10,000, which was made at the beginning. It has grown to 11,255 rands and 9 cents. Now, the amount with which your investment has grown can be expressed in percentage form. You take the original investment of 10,000, this becomes your denominator, and then you take the amount by which the investment grew, which is 1,255 rands and 9 cents. It becomes your numerator there, and thereafter you multiply everything by 100. So you will get 12,5509%. Now, from this example, you can tell that 12% is the nominal interest rate, and this 12% was given when we started. This means that this 12,5509% will be your effective interest rate. And I hope that today you will be able to make a distinction properly between the nominal interest rate and the effective interest rate. In order to find the effective interest rate, you take your formula for compound interest, you calculate the accrued amount, and thereafter you take the accrued amount, which is A, you subtract the principal amount, which is P, and then you divide everything by the principal amount, and you multiply everything by 100. So in short, simply put, to calculate your effective rate of interest, you take A, which is the accrued amount, you subtract P, which is the principal amount, and then you divide everything by P, which is the principal amount, and then you multiply the answer by 100. And that is how the effective interest rate is calculated. So it should be very easy. It should not be difficult for you to calculate the effective interest rate. And basically, the interest rate that we normally use, the one that is given to generate your investment, that is known as the nominal interest rate. And by the way, there is a relationship between the two. There's a relationship between the nominal interest rate and the effective interest rate, as it will be demonstrated by the formula that I'm going to show you in the next slide, where you can be given a nominal interest rate and be asked to calculate the effective interest rate. So the effective interest rate does not always depend on the accumulated amount as well as the principal and so on. You can also use different methods. For instance, here is the formula. You can see in this case, we don't have the A, we also don't have P. So we are not given any accrued amount. In the same note, we do not have any principal amount. What we have got two types of interest rates, the effective interest rate and the nominal interest rate, together with the number of times where interest is calculated per annum. So we can calculate the effective interest rate relative to the nominal interest rate by using this formula. So this formula is also very important, apart from the one that I gave you, where you have A as well as P, then you can use the formula there, which I spoke about. Where the two amounts are not given, then you can use this formula. Remember that this formula just shows you the comparison between the nominal as well as the effective interest rate, together with the investment period. So principal amount is not relevant, as you can see. The principal amount together with the accrued amount, they are not relevant in this case, in my view. Right, an example to calculate the effective interest rate is as follows. Determine the effective interest rate. In fact, determine the effective annual interest rate of 11.8% compounded quarterly. Right. In fact, the question should be determine the effective annual interest rate if 11.8% is compounded quarterly. Now you are given two things here. You are given the nominal interest rate, which is 11.8%, and you are also given the number of times during which this interest is calculated. And we are told that it is compounded quarterly. Remember that a year consists of 4 quarters. So it means your number of times there will be 4, because there are 4 quarters in a year. Right. Basically, you can use the interest rate formula that we just looked at for the effective interest rate as well as the nominal interest rate. And the nominal interest rate, as you know, is 11.8. But remember, that 100 that we have there in the denominator simply means we are dividing our interest. So 11.8 divided by 100. And of course, you multiply that period there, 100 there by M, the number of years or the number of times. In fact, it's 4 quarters, so you divide by 4. So even your exponent there becomes 4, because that is the number of times wherein the interest is generated. So it's generated or compounded quarterly. So it's 4 times in a year. So basically, you can substitute and make the effective annual interest rate the subject of the formula. And in this case, of course, the interest rate or the effective interest rate rather will be 0.12332. And now at this point, you can now multiply by 100 to turn it into percentage, which will be 12.332%. And you can see that it is bigger than the nominal interest rate. It will always be bigger because you are moving from a principal amount to an accrued amount. The only time where the effective interest rate can be lower than the other interest, the nominal one, the only time the effective annual interest rate will be lower than the nominal interest rate is when we look at depreciation, when the value of A is less than the value of P. But for as long as the value of A is bigger than the value of P, then your effective annual interest rate will always be bigger than the nominal interest rate. And I hope that this makes sense, because today we are actually closing this chapter on effective as well as a nominal interest rate. I think that we have done justice to this topic. Now, in the same note, in as much as you can find the the effective interest rate, you should also be able to find the nominal interest rate. Now, in this instance, you are given just one question, very simple. Determine the nominal interest rate compounded monthly, which results in an effective interest rate of 12.4%. So in this case, you are given the effective interest rate. And what you need to do now is to calculate the nominal interest rate. So basically, once more, you have to use the formula. The formula is very clear. We know how to apply the formula there. But then again, we are told this time around that this interest is compounded monthly. And what does it mean? When we say an interest rate is compounded monthly, so how many months are there in a year? So a year consists of 12 months. And that is why the number of period, which is M, the number of period or the number of times wherein the interest is compounded will be 12. So it will be 12 times because there are 12 months in a year. So it means every month the interest will be generated. So basically you use the same formula there. And in order to make the nominal interest rate the subject of the formula, you have to get rid of the exponent, which is 12. And of course, you have to apply now the 12th root. The 12th root of, in both instances, remember that whatever you do in the left-hand side must also be done in the right-hand side. And the 12th root of 1,124. And of course, this will give you 1,009,788,745. And you have to subtract the 1, which was transposed now from the right-hand side, to get 0,009,788,745. So this means that if you multiply now everything by the denominator there, which is 1,200, you'll see that it will boil down to 11.75%. So it will be 0.1175 and so on. But if you multiply it by 100, it will lead you to now 11.75%. And this is the value of the nominal interest rate. Once again, to check or to test my initial argument, you can tell without any doubt that the nominal interest rate is less than the effective interest rate, which is 12.4%. So once again, this shows that the reason why the effective interest rate is bigger than the nominal interest rate is because of the increase. You can see that your value is increasing. It means that because you are compounding monthly, so the principal amount will always be less than the accrued amount. Simply put, the accrued amount will be bigger than the principal amount. And of course, this has demonstrated. And in this case, we can see without any doubt that there is a difference between the nominal interest rate and the effective interest rate. So the call that is made to learners is that learners should not forget that the nominal and the effective rates must apply in examples wherein the investment period and the principal investment amount are of relevance. Using this example, you can modify the compound growth formula by including the time period of the investment, which is multiplied by the actual number of times. And of course, I to the power m stands for the nominal interest rate. M is the number of times interest is calculated, and T is the time period for the investment. And we have spoken about the time period at some point. I'm not going to dwell much into the time period for today. I just want to go back to the example of the depreciation, which has been done using the formula. We know that there are two types of depreciations, as I've already spoken when I began my lesson. We have the simple depreciation as well as the compound depreciation. The simple depreciation is also known as the straight line depreciation, whereas the compound depreciation is known as the reducing balance depreciation. Now, there are two ways in which one can look at the value of the car after some time, after a number of years. Let's look at this car now, which is worth 300,000 rands when it is still new. And the car depreciates now at the value of 12.5% per annum on a straight line depreciation method. Now, what will be the value of the car in 5 years' time? Now, before I can show you the new method there, I want us to go back to the old method a little bit. You will recall that the formula to calculate this particular value is given by the formula A is equal to P open bracket 1 minus IN. And I always say that before you can even look at, before you can even start with your calculation, it's very important to identify the information that is given. So let's quickly identify the given information here. We know that the principal amount is 300,000. That is what we know. We also know that the interest rate is 12.5%. But I've always said to you that before you can even start with your calculations, please make sure that you divide your interest by 100. So this means if you divide 12.5% there, if you divide that by 100, then you get 0.125. So our interest there will be 0.125. And we are also given the number of years, which is 5. So if you use this in a formula, you should be able to take your 0.125 and multiply that by the number of years, which is 5. And it will give you 0.625. And this 0.625 will be subtracted from 1, where you'll have 0.375. And then if you multiply this as 0.375 by 300,000, you will see that your amount automatically becomes 112,500 rands. So this means that when you use this formula, you can just get the amount without a lot of effort. As long as you calculate correctly, as long as you identify the correct values of P, I, and N, respectively. So P is 300,000, I is 0.125, N is 5. So N is the number of years there, which is 5. Now, as I've indicated to you, there's a different way of looking at the straight line depreciation without using the formula. So now we are going to do this without the use of the formula. And of course, you can see that this can, when we look at this, this is what I've done when we looked at the formula. Or without using a formula, this is how we proceed. So the previous one, I've looked at the formula and I found that 112,500 was the value of the car after a period of 5 years. So now let's do it without using the formula. Now the car depreciates at 12.5% per annum. This is what we know. This is what we know because we are given that particular interest for depreciation. Therefore, you divide 12.5 by 100, as I always say, to get 0.125. And thereafter, you multiply it by the value of the car, which is 300,000 rands. This simply means that the car will lose 37,500 rands in value per annum. Because if you multiply 300,000 by 0.125, you get 37,500. So you lose the value of the car, there will be lost every year, will be 37,500. Now, as I said, without using the formula, you can look at in the age of your car. When you buy your car, it is still at 0 age. But by the end of the first year now, you look at how much will the car be worth. So you subtract 37,500 from the original investment of 300,000 rands. This simply means that by the end of the first year, the value of your car will be 262,500. This will be the value of the car. And by the second year, again, it will lose the same value. Remember, this is a simple interest. So straight line depreciation simply means there will not be any changes in relation to the value that is lost per annum. So it will lose the same value every year because we are using simple depreciation formula. And then you can look at the end of the second year, the amount will be 225,000 rands. The end of the third year there, the amount will be 187,500. The end of the fourth year, the value of the car will be 150,000 rands. And at the end of 5 years, you can see that if you subtract 37,500 from 150,000, you will get 112,500. So basically, this is the same value that I got when I used the formula for simple depreciation. It's the same value that I got when I used the formula. So now it should be very clear that you can be able to find these values without using any formula there. Right, this is what we mean when we talk about the straight line depreciation. So in a straight line depreciation, the variables are as follows. A is the accrued amount or the final depreciated amount. So P is the original amount and I is the depreciation percentage. So this percentage will lead to depreciation in value, and whereas N is the number of calculations of depreciation. So you can see once again that if we use the formula, this is what we will come to. You can use the formula. You can see that at the end of the day, you will have to multiply 300 by 0.365, and it will lead to 112,500 rands. So basically that is the final depreciated amount. So you can see that there are two ways in which you can calculate the depreciation value of the car. You can either use the straight line depreciation formula there, or alternatively, you can use the table, which we have just used in order to find the final value there. The last question that I want us to look at is when a deposit is made into a savings account, wherein interest is also earned and the interest is compounded quarterly. I'm taking you back to the number of years. You see, the difference between this and the first one is that in this case, we are told that a deposit of 5,000 rand is made into a savings account which earns an interest of 9.7% compounded quarterly. It's compounded quarterly. Now, the question, which is very clear here, is how long will it take for this investment to triple? How long will it take for the investment to triple? So once again, you need to be able to identify the given information. There is no doubt that P, which is the principal amount, is 5,000 rands. There's also no doubt that we are given the accrued amount, although it is not written there in figures. You can't see the figure in this question, but we are told that the investment triples. When the investment triples, it means you multiply the original investment by 3. So if you multiply 5,000 by 3, you get 15,000. So it means the investment is tripled. So this simply means that the accrued amount is 15,000 rands. And we also know that the interest there is 9.7%, which must be divided by 100. If you divide 9.17 by 100, you will be able to see that you will get a value of 0.097. And this is the value that you can use. So once again, this amount is compounded quarterly. So it means we are going to use the compound interest formula. If it is compounded quarterly, then it means it's 4 times in a year. That is why you will be able to see that when you use this particular solution, you can see it's 4 times a year. So you multiply the time there by 4. So basically the logs come into play because your unknown there is an exponent. So if you multiply t by m, the time there multiplied by the number of times, which is 4 because it's quarterly, then you will see that the t there will be 11.46. And this simply means that the time period will be multiplied now by 12 to get the months. Remember that. So it will take Karen 11 years and 5.5 months to triple her investment. It will take Karen 11 years and 5 years to triple her investment. Now, as they say, a reasonable probability is the only certainty, and this was said by E.W. Howe in mathematics. If you have any questions regarding this lesson or any future lessons, please feel free at any time to contact us at STEM Digital School at africateamgeeks.co.za. Until we meet again, thank you very much indeed.